Okay, here's a little bit about how the periodic table is organized in its modern form. We'll show you some key features here, and let's go ahead and get started. Screencast 6.2. Well, here you go. Here's your average periodic table. There's a few details added. You might not normally see it spread apart there. You might not see so many of these numbers and letters. But take a look at each one of these features and try to recognize it. The key thing to realize about the periodic table is the main feature that it's based on is really the electrons. Okay, it's true that the number of protons increases as you read it like a book, but the properties change every time you add a proton. However, there's patterns. The patterns that Newlands and Mendeleev recognized. They really try to show them with these columns, and that's really the critical part. They have common electronic features. Specifically, the columns all have the same number of valence electrons. And there they are listed right there. Oh, did you like to see that? Let's do it again. There they are, the valence electrons. And you see, if you look at it, it varies from 1 to 8. And there you go. So please write 1 to 8 right there. Charges. As a result of these valence electrons, the charges necessarily ensue, and they're listed right right there. Okay. And here's how it goes. Charges 1, 2 varies. 3, 4, 5, 3, 4, negative 3, negative 2, negative 1, and 0. So the charges vary roughly from -4 to +4. We may see cases later in the year where they get slightly higher. This is in accordance with Dalton's observation that atoms tend to combine in small whole numbers. Orbitals. We talked about electrons recently, so let's notice that there's lots of orbitals here. And they are listed along there. Technically, an orbital is a pair of paired electrons, but people normally call these the 1s orbital, the 3p orbital. Really, it's 3 pairs of orbitals, but anyhow, the orbitals vary from 1s all the way up to the 7p group. And they're divided into, 4 main blocks, shown here. S, P, D, and F. You can remember it based on these little letters here. Someday, if they get one big enough, they might go to the G block. Anyhow, they're S, P, D, and F. Periods, what the heck does a period mean? In science terms, it means a row going across. And as you go, they increase by 1 atomic number. That means 1 proton added to each one to create a new element. The groups or families are more important. In my opinion, those are the columns. And so the group 1 is a specific column. The group 8 is a specific column. I'm going to use the old-fashioned terms. I'm not going to say 18 like you might see in some of the modern ones. I like these old numbers 1 through 8. Nice and simple. Lots of different groups you should know about. Some common ones. They're all listed up there, so you don't have to memorize them, but let's check them out. Alkali metals are right over here, the group 1s. Alkaline earth metals are right here, the group 2s. The halogens, let's go all the way over here, because this is another just common name, group 7s. Fluorine, chlorine, bromine, etc., group 7. And the noble gases are group 8. They don't do anything at all. We can also subdivide the periodic table into metals, nonmetals, and metalloids, and it's all based on that staircase. See the dividing line right there? Noble gases 8. Metals, nonmetals, and metalloid, it's all about the staircase. Metals are to the left of the staircase. Nonmetals are to the right of the staircase. Metalloids are in green, and they're more or less on the staircase. I think that's it. Whoop. There's those metalloids. This is Screencast 6.2.